All right, so in this video, we'll talk about the phenomenon known as precession. It's a phenomenon that comes from the fact that Earth is not a perfect sphere. Okay, it's a little bit oblate or it's a little bit squished. Right, so you can do this same effect if you take a basketball or an orange or a spherical balloon and you grab it on top and bottom and you compress it. What's going to happen is that the north and south, or the top and bottom, will compress in. At the same time, the middle will bulge outwards. So it won't be a perfect sphere. And so the fact that the sun exerts a gravitational force on the Earth, this causes a precession. Okay? And Earth spins about its axis, right? We see that right here. That's its spin axis, or its daily axis, which points towards the North Star, Polaris, right? It's actually pointing towards the North Celestial Pole, but Polaris is very close by that point. Okay, that's the spin axis. That takes 24 hours. But that axis itself takes a much longer time to spin around in the sky. And that time is more close to 26,000 years. Okay, so for right now, our North Star, or the North Celestial Pole, is very close to the star Polaris. In about 13,000 years, it'll be on the other side and point towards the bright star Vega. Okay, and so this is what Earth is doing. It's much, much too slow to notice in any given year, right? Even from year to year, even in 50 years to the normal observer. Okay, much too slow to ordinarily notice. But it acts just like a spinning top. Right? Tops spin very quickly about one axis, and then that axis itself moves much more slowly about another axis. So these two motions are happening simultaneously. On the left side here, that's an image of the sky close to the North Celestial Pole. So this line in yellow, that's the path of Earth's pole, right? Or of Earth's North Celestial Pole. We can see Polaris right there. It's really, really close by, right? So right now, about 2000 AD, our North Pole is, well, roughly there. And Polaris is roughly there. Okay, so that's our North Star. Year after year, decade after decade, century after century, millennium after millennium, Earth is spinning, and that axis is also spinning, right? Also precessing, actually, in this direction, ever so slowly. Takes 26,000 years to go one time around. So, in about 13,000 years, on the other side, it'll be closer to, or closest to, the bright star Vega, one of the brightest stars in the sky. So for humans on Earth, if there even is humans on Earth in 13,000 years, that will be their North Star. And Polaris will just be an ordinary star out in the middle of space, not special at all, right? You may remember from ancient astronomy, the ancient Greeks had a North Star called Thuban, right? 3000 BC, 5,000 years ago, Earth's axis pointed towards Thuban, right? And so about 2,000 years ago, there really wasn't a North Star, right? So over time, the North Star can change due to this precession. And this incurs some interesting effects as far as the constellations. On the right side, above, is the condition now, right? The northern hemisphere, we have that in January and July on the left and right. Northern hemisphere points away, so we call that January. So in January, at nighttime, we're looking over here. Okay? So we see constellations like Gemini. Orion's a big one, right? Orion got the star one in his belt and here, and he's fighting the bull and all that. So we see that at night in the wintertime. In the summertime, what is over here, we see constellations like, well, Scorpius, or we see Aquila, the eagle. Well, constellation's up now, right? Aquila, the eagle, Lyra, the lyre, Capricorn, the goat, right? We see constellations like that. However, in 13,000 years, look, Earth's axis will be flipped this way now. Instead, it was that way, right? Remember, it's spinning like a top. So when it's halfway around the precession in the northern hemisphere, at the same point in the solar system, the same side of the sun, now it's summertime because the northern hemisphere, that North Pole, is facing towards the sun. And so at nighttime, guess what? The stars that were in the winter 13,000 years ago will be in the summer now. So Orion will be a summer constellation. Taurus will be a summer constellation because those are the stars on this side of the galaxy. On the other side of the galaxy over here, the stars that were or are at night right now, Capricorn, Aquila, Lyra, those will be considered winter constellations in 13,000 years. Again, because our axis will have flipped. And so what changes? It's not the stars' positions, it's what we call the months of the calendar year. Right? We're constantly adjusting because of leap years and whatnot. So we call the days and the months of the year what we do because that's how, well, the seasons are, right? We call summer in the northern hemisphere when the northern hemisphere is pointing towards the sun. And we call January a winter constellation because that's when the pole is pointing away from the sun. So it doesn't matter what constellations are in the sky, they'll just change with the seasons. And so this also brings us back to the zodiac once again, okay? So right now, let's see, right now, the March equinox constellation, where is Earth, right? In March 21st, Earth is right there. We're looking towards the sun, so the sun appears to be in front of the constellation Pisces, right there. 2,000 years ago, in the past, Earth's axis has precessed since then, right? For the past 2,000 years, Earth was right here looking back this way in Aries. So it used to be March 21st when the sun was in Aries because the axis has precessed like a top. And so you may remember this from the videos in ancient astronomy, but with the ancient Egyptians and the ancient Greeks and the Mesopotamians, their March equinox constellation was Aries, right? In 2,000 years from now, the March equinox will lie in the constellation of Aquarius. You may have heard of the saying, the age of Aquarius, right? Well, that's what they're talking about. In 2,000 years, the March equinox will be in Aquarius. And this is all due to the precession, the very slow precession of Earth's axis, because Earth is, well, spinning like a top.